Hello and welcome to my video. This is a video for Calc 2 Section 6 and it's an area problem, so it should be fun and hard, but not too hard, harder than just a regular integral problem. And let's get to it. So what we have here is a y equals cosine squared of x and a y equals sine squared of x, and we have two boundaries, pi over 4 and negative pi over 4. If you want to solve for the region between these two boundaries, you're going to need to know this formula. This formula right here is the area formula between two boundaries, for the region between two boundaries, if you really want to get into it. Now, in order to find these two problems, because these are the major two ones that you need to find, you need to know which one of these functions is on top and which one's on bottom. Because that's going to determine where you put them. Now, I already know, but you can graph on your calculator if you want to. You can pause it right here and graph on your calculator, but I already know which regions go where. Cosine squared is on top and sine squared is on bottom. So we can just put this equals negative pi over 4 and positive pi over 4. Cosine squared of x minus sine squared of x dx. So there it is, our integral. You can use a graphing calculator to find the regions, but just plug them into your y equals x, and then plug pi over 4 and negative pi over 4 into your window, and for x, and just graph it, and you'll find out that the graph looks something like this. So there you go. And that's how you realize that that the two regions are like this. This is how you make the formula. Now, if you want to solve this my way, the easy way, because I like easy, I like simple. I don't like things complicated like this, but it's not too complicated, but still. If you want to solve things fast and quick, my way, you need a TI-84 plus CE. You could try this with a TI-83, but I don't think you will be able to. This is how my modes are, and it's very simple. This is easy. This is my way. And if you don't want to do it, then that's too bad for you. So you just click the math button right here, right? And it takes you to this place. Don't press any buttons except for this one. Press 9 right here. As soon as you get there, press 9. And look what that does. Interesting, huh? It lets you put in an integral. So it's really simple. Just plug that integral in. Pi, negative pi over 4, and pi over 4. And then just put in cosine of x squared minus sine of x squared. And then just put a dx at the end. And look what that gives me. That gives me the answer right away. No muss, no fuss, no taking up a page, front and back page to get this equation done, or just taking up a whole page to get one answer. Just use a calculator. This is, again, a TI-84 plus CE. So it can go for $50, $60, maybe even $100, but they're worth their weight in gold. These calculators are very useful for Calc 2. I don't even think you'll get through Calc 2 without these calculators, to be honest with you. But that's just my opinion, not a fact. If you really want to get through these, you know, these certain Calc 2 teachers, they teach different ways. Not a lot of homework, some with not a lot of homework, some with others with a ton of homework. If you want to get through homework fast, get this calculator. If you can't afford it, there's always the old-fashioned way, but it's long and it's going to take up a lot of paper. So, fortunately, I know the old-fashioned way too. So, if you don't know your trig identities, you're not going to get this. But if you do know your trig identities, then you'll know that cosine squared of x and minus sine squared of x equals cosine 2x. So, let's put it right here. Negative pi over 4, positive pi over 4, cosine 2x dx. You might even need to know these for some of your tests, which can be a pain. But hopefully you get a cheat sheet. If you don't, I feel sorry for you. But so we know that it's cosine 2 of x. Now, in order to do this, you need to use u sub. In order to do this, you need to get rid of that 2x. So u equals 2x, and then du equals 2 dx. You divide by 2 to both sides, and you get du over 2 equals dx. Now, in order to do this, you have to change your boundaries. So you put these boundaries, each of them, into the u sub problem, and you multiply. So you get 2 times plus and minus pi over 4, and that equals plus or minus pi over 2. That's your new boundary. So the antiderivative or integral of this equals, let me show you, pi over 2 negative pi over 2 positive cosine 2, or just u, du over 2. Now we just put that 2 in front of the integral and we get 1 half 2 integral negative pi over 2 cosine of u du. Now all we do plug that is to get the antiderivative, which we know is sine. So all we say is 1 half, and put some brackets, sine of u, and another bracket, and we say pi over 2 pi over 2. Okay, that's all we need to do. This is a negative pi over 2, and this is a positive pi over 2. That's all we need to do. So we plug that into the equation right there. Plug that in. If you don't know what you're doing, then you're just plugging these two into for u and subtracting them both. So you get 1 over 2. Let's keep these brackets right here. Sine pi over 2 minus negative pi over 2 and the brackets. Now this sine over 2 minus negative sine negative pi over 2, you get 2 times 1 half. Now, if you don't know the answer to this question by now, I mean, come on, it's just one. That's the answer. So this is an area between two regions formula or problem. It's a bit longer if you do it the ordinary way. It's way shorter if you do it my way with the calculator. You just go to math and you click the button number 9 and you can plug in any integral you want, whether it's with trig functions or without. And you just you just can do this so much faster with this type of calculator. I mean, it's ridiculous. You can solve it. This is what, like, I'm gonna say 7 minutes of work, 6 minutes of me showing you how to do this, and solved in 1 second or 3 seconds, whatever. If you want to get real on me, but yeah. So this is how you do an area between two regions problem. If you don't have one of these two, that's a completely different problem. But I mean, if you don't have two functions, you won't be able to get this whole area formula, and that sucks. Um, I hope you liked the video and you liked um, the how I solved it quickly, and then how I solved it the ordinary way, the old-fashioned way, if you will. They're both pain. This one's a pain in the butt, but the calculator definitely comes in handy with these types of problems, integrals, and I think it's worth the investment. If I had gotten this sooner, I would have been solving these faster than you can blink, but I didn't because I was a cheapskate. Don't be a cheapskate. Get these and get them fast. Take advantage of this opportunity. These are worth their weight in gold. I am not joking. If they can solve integrals this fast, imagine what else they can do. They can do parametric, polar. They can do sequences and series. Or well, I don't know if they can do sequences and series. They can do sequences. They can't do They can't do series. They can do sequences. They can do degrees. They can do radians. They can freaking do anything. They can do most of what you'll find on Calc 2, especially TI-84. They're the most advanced. These are the most advanced. So if you're going for Calc 3 or Calc for an A in Calc 2, I would suggest you get these calculators. Or if you're just stockpiled full of homework, I would get this calculator. This calculator will save you time. It'll save you on paper and on pencils and on erasers. So doing it this way is fine, but it's not It's not if you're trying to save time, use the calculator. And I hope you liked my way, and I hope you liked how I solved this. This is the old-fashioned way. But thank you for sticking around, and if you liked the video, please give me a thumbs up. If you have any questions or comments, put them in the comment area, and I'll see it. And thank you for watching my video. Thank you, and good night.